Alright guys, let's do the second part of the SCR lab. So the first part, what we did was we took the SCR and we tested it out with a digital multimeter. And then we put it into a DC circuit and we saw that it only conducts when it's forward biased and it has a brief pulse of current to the gate. So now let's see how it responds in an AC circuit. We need the breadboard, we need the 120 to 24 center tap AC supply. We're going to use the SCR, 47 kilo ohm resistor, 1 kilo ohm load resistor, 10 kilo ohm variable resistor, so we use a potentiometer, and a 0.47 microfarad capacitor. Once we're done with the lab, you can play around with different capacitor values and resistor values to see how you get better control or less control over the SCR. But let's try these values out for now. Now the circuit that we're going to set up is right here. So we've got the SCR in series with the 1 kilo ohm load resistor. And that's right across the source. There's our source coming from the 24 volt AC supply through the SCR, through the load, and then back to our other side of the 24 volt AC supply. And to fire on that SCR, we need this pulse of current to the gate. Well, to determine that pulse of current to the gate, we're going to have a 47 kilo ohm resistor in line with our potentiometer. So by changing that potentiometer, we'll be able to vary the voltage to the SCR or the current to the SCR gate. And then to phase shift this whole circuit here, we're going to use the capacitor. And that way we're going to try and get a little bit more than 90 degrees control over the SCR. Usually with these, it's hard to get over 90 degrees of control over the SCR conducting. But we'll see how it goes with the 47, the 10 kilo ohm pot, and the 0.47 microfarad. Okay, let's take a look here. Before we go on, I just want to note here that the scope probe is going to go here, and your alligator clip for the scope is going to go here on the other side of the load resistor. Okay, looking at the way that we've set this up, first of all, we have the SCR in line with our load resistor. Okay, make sure that, again, that the SCR has not been shorted out. Okay, so you can see that I'm placing the two SCR pins right here, where there is no jumper there, and I'm keeping the gate separate there. If I was to put it in here, well then I am no longer having conductivity here with the gate current. So make sure that you put it into the right position and that you're not shorting out any of your components. You can just make out, it's hard to see on the camera here, but you can just make out here inside the Festo unit here, the three leads coming off of that SCR. It's almost impossible. There's the heatsink there, and on the other side, just twist this a little bit, you can just make out those three leads off the SCR there. If you want to take a good look at it, you can open it up slowly without cracking this plastic, and you can take a look at the components. See? Watch where you're putting it, because like a donkey, I'm going to put it in the wrong position. So now we've got this guy going down to our load resistor. Again, if you want to see any of these components, they're right there within the window of the Festo units. Okay, so that is our 1 kilo ohm load resistor that's going to go in line with our SCR. Now over here we've got a 47 kilo ohm resistor, and we got a potentiometer here. And in line with that, we've got an AC capacitor, and for this guy, we're going to use the 0.47 microfarad capacitor. Again, you can take a look at the components in the window here. There's our AC capacitor that we're going to use for this lab. It's going to phase shift the current going into the gate. So let's see, we're going to keep this current going here, phase shifted by the capacitor and across to the other side of the source. And then from the pot, we're going to go into, you can see that we have conductivity from here over to here and into the gate of the SCR. Excellent. Okay, that is coming from our AC supply, so you can see one of the supply cables up there to the bus at the top, and another cable here at the bus at the bottom that feeds our return. And then that's all coming off of here, our 24 volt AC supply. Okay, and you can, just to note, just that you're on line 1 and line 2. We're not making use of the center tap at this point. Okay, let's go back to the lab here. If we're taking a look at the lab, the next thing we need to do is do a diagram. So take a look at the circuit that we've set up here and try and do a nice diagram here. SCR in line with the load, 47K in series with a 10K pot, in series with a 0.47 microfarad capacitor. Beauty. Next thing it says, note that the ground clip of the scope probe should be referencing 0 volts. We already talked about that. Adjust the variable pot until you achieve 90 degrees of control, or the SCR is conducting at the peak of the voltage waveform. This should allow 50% of the positive waveform to be visible across the load resistor. All right, well, let's set it up first and then we'll take a look. So using the scope, measure the waveform across the SCR first. All right, so we've got this set up and we've got our scope probe here. We've already calibrated the scope probe. At this point, I've got the scope probe on, let's just set, focus this, there we go. I'm on times 10 right now. And the settings that I'm on the scope, I'm on channel 1. I'm on 1 volt per division, so times 10, that would be 10 volts per division. And then the time for division, I was looking at between 20 to 50 milliseconds for the time. Okay, make sure that these are cranked all the way, otherwise they'll skew your values. All right, so now we got to hook up the scope probe. So first thing they want us to look at is the SCR. So let's connect the alligator clip to the cathode, and you can just get it to grab onto the cathode there. And then we're just going to take our scope probe and make contact with the metal pin on the unit here. Okay, now taking a look at the screen, hopefully this is coming through here, you can see that we're getting almost the full waveform there. And by adjusting the potentiometer, let's see if I can get this scope probe to sit here. That's the only bad thing about this scope probe, is that I only have 2 hands. Beauty. Okay, so right now I'm going to adjust the potentiometer, and you can see here that I can get the SCR to fire on earlier, or I can get the SCR to fire on later. So what I'm doing is I'm adjusting the potentiometer and deciding when that gate current comes in to the SCR. You can see that I can't get the full waveform here. Let's change to a different time setting here. I can't get the full waveform because at this point in this portion of the waveform, there's not enough current to keep the SCR on to get the full 180 degrees of control. So by changing the potentiometer, watch this. This is very cool. So by changing the potentiometer, we can now time when the SCR turns on, right? So you can see here that the SCR is turning on right here, and the remaining portion of the waveform should be going to the load. If I want to turn it on earlier, then I'll adjust the pot here so that less of the voltage is dropped across the SCR, and the remaining portion of that waveform should be going towards the load. And we can get this right down to here where the SCR is firing on really early, right? So you can see it's just getting up to here, getting enough current to turn on the gate, and the remaining portion of this positive waveform is going to go to the load. So we're doing that by adjusting this potentiometer here. By changing the potentiometer, we're changing the conduction angle here on the SCR, and we're getting more, so this would be more voltage to the load or less voltage to the load. Okay, we were supposed to set it up at 50% there, so that looks pretty good, where it's basically allowing that gate current to happen at the top of the positive waveform. The negative portion of the waveform is still going to go through or be visible, or be visible across the SCR. Remember that on this portion of the circuit we have AC, and the SCR is basically like a switchable diode. So we're only able to control one portion, or in this case the positive waveform right here. In order to control the bottom part, we'd have to have another SCR, which essentially would be a triac. Okay, so we're only able to control half of the waveform here, and we're doing that by controlling how fast or how slow the capacitor builds up in voltage and then shorts out across that gate current or the gate circuit of the SCR. Beauty. So we'll get her halfway there. Looks good. Okay. Now if you wanted to to draw this out, you could do just this small portion of the waveform. I decided to go with this one, where you can see a number of different waveforms coming through. Unfortunately, with the cathode ray tube here in the camera, it's a little bit, stop and go here on the camera. But you can get a pretty good idea in that the SCR is now having the voltage increase. At this point, the SCR turns on. The remaining portion of the waveform goes towards the load. It goes to 0, the SCR turns off, and then this portion is dropped across the SCR. Again, the voltage increases. Gate current goes to a point where it's going to turn the SCR on. This portion goes towards the load. This portion is dropped across the SCR, and then the load, SCR, and the load. Okay. The settings that I had there were 50 milliseconds. I got 1 volt per division, but I'm on the ×10 probe setting. Okay, next thing that they're asking us to do is to now look at the load resistor. Well, taking a look back up here, well, this is the SCR. Think of the SCR as just a switch. When the switch turns on, the remaining voltage, this is always happening in the background. This is the AC waveform. So this remaining portion from here to here is going to go towards the load. So we should see something like this. On this waveform, I had it at 50 milliseconds, 1 volt per division again, and on the ×10 setting. So now we're going to look at the load resistor. So again, the alligator clip is going to reference the negative portion of the circuit. Okay, you can just connect it in there, and then you'll have to work with your partner to, it would be good if I got something where I could actually have this sit nicely. Grab on there. Come on. There we go. Okay, so now you can see there's that portion of the waveform, the remaining portion of the waveform that came from the SCR. Let's see if we can just get this to sit nicely. Yes. Okay. There we go. So right there is the remaining portion of the waveform. So the SCR, basically the waveform is coming like this, increasing to a value where the SCR turns on, and now this is what we're seeing across the load. Okay, by changing this potentiometer now, we should be able to change the angle at which the SCR is turning on. So if we want more voltage towards the load, we're going to fire on the SCR earlier. Okay, so here you can see that the SCR is turning on earlier, right? It gets up to here, starts conducting, and the remaining voltage is now going towards the load. If we want to have the SCR turn on later, well then more voltage is dropped across the switch, which is basically the SCR, leaving us less voltage towards the load. That's 90 degrees of control, and the beauty of this circuit, I had to play around with the values for the resistors and capacitors, and we can almost get 180 degrees of control here. So there's a small portion going to the resistor. You can see that right here it gets a little bit funky, right about there, right? So there is halfway, there's 90 degrees. Past 90, it's really hard to get a decent waveform here. There's only a small portion of voltage going towards the load. Okay, there's conducting at 50%, and then here we can turn the SCR on really early and get the full almost the full positive going towards the load. You can just make out here that a small portion of this waveform is missing because it still has to drop across the SCR, right? The SCR has to turn on first. We're not going to get the full positive waveform there. If we change this, then you can see how much of the waveform is going towards the SCR, towards the load, and by changing the conduction angle of the SCR, now we've got basically 50% of that voltage going towards our load. Again, one more time, if we want more voltage, then we're going to have the SCR turn on earlier. If we want less voltage to the load, then we're going to have the SCR turn on later. Okay, so that's pretty good. That's at 50% where they asked us to do a diagram, you can either do this guy right here, right, the single waveform that you can see there. I decided to go with this one to see a number of different waveforms. So again, the SCR is now climbing in value, turning on, and the remaining portion here is going towards the load. Then it reduces in current, SCR turns off. This portion of the waveform gets dropped across the SCR. It increases in value, gets to a point where the gate turns on the SCR and the remaining voltage goes towards the load. Dropped across the SCR, gate turns on, this goes towards the load. And finally this goes towards the load. So it's a very cool circuit in that you can change the timing by changing the potentiometer, and that decides when the capacitor is going to charge and discharge in the circuit. If we take a look at that circuit again, the capacitor is essentially discharging through the gate circuit and back to here. So we can have build up a voltage here. Current then is able to go through the gate and go to the other side of the capacitor, firing on the SCR. And the beauty of the SCR is that once it's on, it stays on until the voltage decreases. Then we're going to have to fire it on again with a little pulse of current. So you can see that the voltage increases and it always turns on at the exact same point because we have the exact same voltage waveform going into it. At that point it turns on and the remaining voltage goes towards the load. Beauty. And last thing we need to do is take a voltage reading across the load resistor with the multimeter. So this is mess. Watch this. So we're going to take the multimeter. We're going to be on a DC voltage, right? Because we have AC being rectified to DC. And we're going to go across the load resistor. So remember that the SCR is rectifying the AC into DC. It's a switchable diode. So we're on the DC mode. And we're taking a look at the voltage across the load resistor. That's our 1K resistor. And if you look at this voltage wave that we're seeing on the screen here, it's messed. It's 2.5 volts. So it's very hard for the multimeter to get an accurate reading of the voltage because of those waveforms that are happening. Okay, so I wouldn't rely on the multimeter to take that voltage reading. Okay, last thing we need to do is take a look and finish off our answers here. So was the DC voltage reading accurate? Not really, not at 2.4 volts DC with 24 volts going into it. Is this a pure half, sound very good, I have to change the wording there. Is this a pure half sine wave showing 180 degrees of conduction? Well, it's almost 180 degrees. We had good control from 0 to 90. After that, it went a little bit funky. Is this waveform AC or DC? It's a DC waveform because we're taking the AC and rectifying it to DC. Final notes on the SCR. The SCR is going to conduct only when it's forward biased. The SCR will only turn off if the current through it is reduced to below the holding current level, which is effectively 0. The SCR will not conduct when forward biased until a small positive current is applied to the gate terminal. And the delay angle plus the conduction angle will always total 180 degrees. If the conduction angle is varied, the average value of the output voltage to the load will also vary. That means that once we change the potentiometer, we're changing the conduction angle, or when the SCR is turning on, and obviously we're then determining how much voltage is going to go to the load. Digital meter will not give accurate readings in an SCR circuit due to the wave shapes that are produced. Excellent. All right, guys, thanks very much. Hopefully everything makes sense on the SCRs. If you have any questions, you can post them in the video here or see me in class.